Hey guys, in this video, we're going to do some mixed derivative problems. So, what you want to do is identify if it's a sum or difference, or it's a product, a quotient, or a chain. In these examples, they all appear to be a sum or difference of monomials, or what we call a polynomial, except for this guy here. But I think I can do something with number 110 to make it into the sum or difference. Okay, so let's get started with this guy. Remind yourself that in order to take the derivative, all you have to do is take the exponent, multiply it by the coefficient in the front, which is a 1. So 7 times 1 is 7, x, and now we're going to reduce the exponent by 1, 6. Also remind yourself that any constant, the derivative is 0. So let's try the next one. 3 times 5 is 15, x squared. The derivative of negative x is negative 1, and the derivative of any constant is 0. The next one, 2 times 4 is 8, x to the first minus 1 times 7 is 7, but there's a negative in the front, x to the 0, which is just 1. This guy right here, 32, x to the third, plus 18, x to the first. This guy here, before I do that, that looks like a quotient, but because in the denominator there's a monomial, what I can do is rewrite this. So I'm not going to put f prime just yet. I'm going to call this x to the fourth plus 2x to the negative 1. And now I will take the derivative of that. To take the derivative, it's going to be 4x, reduce this by 1. Negative 1 times 2 is negative 2. X, reduce that by 1. And it looks like this. We should never leave exponents in negative form. So since the x is the only person who has the 2 that's negative, it goes on the bottom. And that's how you do these problems. Continuing with the problems, now we see that this looks like a product. But because this guy in the parentheses is raised to the first power, I'm going to distribute and then take the derivative. So 3 times 18 is going to be 54. X times x to the fourth is x to the fifth. 3x times 13 is 39x. And then we have x plus 1. Now, we're going to take, this is just f of x. We're going to take the derivative of this guy, so I'm going to indicate this by f prime of x. This derivative is just the monomial. 5 times 54 seems like it's 270, x to the fourth. This guy here is going to be a quotient rule because I have an x in the numerator and an x in the denominator, and the x in the denominator is not a monomial. So how do we do the quotient rule? I'm going to keep the bottom, derivative of the top, minus keep the top, derivative of the bottom, all over the bottom squared. Be sure that you do not reduce this guy with this guy because that's incorrect. So you should probably try to clean this up a little bit because it looks like certain things cancel out. So let's see what happens here. We get 39x plus 39 when you distribute this here. And then you get minus 39x times 1, which is negative 39x. So this goes out with this. And you're basically left with 39 on top and x plus 1 to the second power. So your answer is going to be x plus 1 squared. And that's going to be our derivative for this guy right here. Okay? Now, that's how you do that guy. This guy here looks like a product, but once again, it's to the first power. You should distribute. So I'm going to do that on a separate. So once again, it looks like a product, but because this is to the first power, I would prefer to not do the product rule and FOIL this out. That's going to be 2x to the third minus 3x plus 4x squared minus 6. You should probably arrange them in order, but I'm not going to. 2 times 3 is 6, x to the first. This is going to be negative 3, and that's going to be 8x to the first. You don't have to put that 1 there, but this guy ends up being 0, and then, this guy here is 6x squared. 3 times 2 is 6. Reduce this guy by 1, and this guy here, and that's what you would get this if you did the product rule, but anytime you have something to the first power, you should distribute it. Okay. In our next 3 examples, we're going to do the same thing. In this problem here, I'm going to distribute this. So when we multiply a fraction times what I call another fraction, you do top times top, bottom times bottom, and you get this here because x squared is really x squared over 1. So you multiply this times this and this times this. Now you're going to reduce this. So remember, this is f of x. So f of x is going to be 2 plus 5 over x to the first. Since that's a monomial in the denominator, I can rewrite this as 2 plus 5x to the negative 1. Now I'm ready to take the derivative. And notice I don't have any products or quotients. The derivative of this guy is 0. The derivative of this guy is negative 5x to the negative 2. And as I stated earlier, we don't like exponents to be negative, so this is my answer to 113. Number 114 is actually not a quotient, because if you guys recall from my earlier videos, quotient means there has to be an x in the numerator and an x in the denominator, and there's no x in the denominator. This is just 3, which is just a coefficient. You can go like this if you want, or you could just factor it out to be 1/3 and do the power rule. So I'm going to leave it like this for you guys, and we're going to do f prime of x is equal to 3x squared over 3 plus 4x to the first over 3 minus 0. And so this gives you this, and you're left with x squared plus 4x over 3, and that's what f prime is equal to. If you do not put f prime is equal to it, then it is. So in this problem here, I see there's a monomial, and that in the denominator. That's why I'm not going to do the quotient rule. I'm going to give each piece of the numerator an x squared, and then I'm going to reduce this. So x to the third, x squared, boom, x squared, x in the bottom, x squared, and then I raise everybody up to be a negative, and now I can take my derivative. So that's 4, that's positive 2x to the negative 2, and that's negative 2x to the negative 3, and then you're just going to have to rewrite the negatives, and you don't have to make it into a common fraction. So we can just keep it like that, and that's how you do that problem. In this problem, you have no other choice but the quotient rule, because x squared minus 4 is factorable in the denominator, but x squared plus 4 is not, so nothing cancels. You should always try to see if something cancels. How do we do the quotient rule? We're going to keep the bottom, derivative of the top, which is 2x, minus keep the top, derivative of the bottom, which is 2x, all over the bottom squared. Don't ever touch the bottom. That's going to be 2x to the third minus 8x. When you clean this up, you must clean it up, minus, that's going to be 2x to the third. I'm going to do that. 2x to the third plus 8x all over the bottom squared. You are going to distribute this negative, and you'll notice this cancels out with this, and negative 8x, and this becomes negative 8x. You get negative 16x over x squared minus 4 squared. That's how you do that.